So
Yeah.
we only
Hello.
need Chris, right? Is everyone else already?
Um, Professor Ka is coming.
Okay.
Can you get hold of him? If not, we can take a screenshot and go ahead and start it, and then we can take another green screenshot while during after your fireside chat, maybe.
Sure. Yeah, yeah. I don't think I'm trying to join now. Okay. Google and I see. He does not have the link. Let me send him the link. I think he's
Oh, he's waiting for the link. Okay.
yeah. Let me give him the link. He's
Okay, thank
busy,
you.
so he didn't
Understandable.
really follow up with every instructions.
Uh-huh.
Chris got an error when he tried to using the link. Is
Mm,
is it possible? Like, oh yeah, Chris is joined. Okay, cool. I
great.
thought that you have the
Yes,
air,
I saw his name on it. Hello,
so
Chris.
great.
Glad to have you with us. Can you hear me? Hello.
All right, now
I
you can
think
hear me, right? Now you can hear me.
okay,
Yes, now I
cool.
can
Sorry.
hear you. Great.
You know how it
Great.
is. Every time you join a new meeting, like nothing is synced
Yes,
up. You have to switch devices and all that.
it takes the time. Perfect.
Yeah.
Chris, since you don't have PowerPoint, then you have your unified background. Perfect. And so now, is Professor Ka coming soon? Or should we take a screenshot right now and then our team can Photoshop him in?
I think that's a good idea.
Yeah, okay. Why don't we all turn on our video and then our team can do a quick screenshot before we officially kick off our event. Do we have everybody? Yes. Okay. Cheese. Okay, Xiaoling, please let me know when you're done with the screenshot. Okay, perfect. Now we will move on to officially starting the side event. Okay.
Privilege me.
Yes. Good morning, good afternoon, and good evening. It's my great pleasure to welcome all of you, our distinguished guests, speakers, and participants from all around the world to this official site event. We're gathered here as part of the 10th Multi-Stakeholder Forum on Science, Technology, and Innovation for the Sustainable Development Goals, also known as STI Forum 2025. Our session today is titled Data+AI for Sustainable Industries Growth, and is jointly organized by the World Digital Technology Academy, WDTA, and the Cloud Security Alliance Greater China Region, CSA-GCR. My name is Norma, the Global Director of Talent Development for WDTA's DG Breach program, and I have the honor of serving as your moderator for this important dialogue today. Throughout today's session, you'll hear from experts who aren't just talking about innovation, they're building real solutions. We'll be focusing on 4 key themes: how AI uses data, how better data makes smarter AI, real-world case studies across industries, and the collaborative efforts needed to do all this responsibly and at scale. Thank you again for being with us. We begin today's event with a distinguished leader whose contributions to global digital governance and inclusive innovation continue to shape international collaboration. Let's welcome Professor Peter Major, Vice Chairman of the UN Commission on Science and Technology for Development, founding Chairman of the World Digital Technology Academy, and Chairman of the UN CSTD Multi-Stakeholder Working Group on Data Governance. Professor Major, the floor is yours.
Thank you, Norma. Ladies and gentlemen, welcome you all to the Data+AI event of the STI Forum. I'm deeply honored to speak on behalf of the UN Commission on Science and Technology for Development, UNCSTD, and the World Technology Academy, WDTA, as well as the UNCSTD Multi-Stakeholder Working Group on Data Governance at the Data+AI side event for the 10th STI Forum. The 10th Multi-Stakeholder Forum on Science, Technology, and Innovation for Sustainable Development Goals is a pivotal platform for advancing sustainable, inclusive, and evidence-based solutions to achieve the 2030 agenda of the SDGs, leaving no one behind. This year's theme, Advancing Sustainable, Inclusive, and Evidence-Based Science and Technology Solutions, emphasizes transformative innovations focusing on SDGs related to health, gender equality, economic growth, ocean conservation, and global partnership. Our side event, Data+AI for Sustainable Industry Growth, aligns seamless with this mission by exploring how data-driven technologies and artificial intelligence can drive sustainable industrial development, foster economic resilience, and address pressing global challenges, accelerating progress toward inclusive and equitable growth as outlined in the SDGs. As an essential component of the 10th STI Forum, this event will delve into how data and artificial intelligence technologies can drive global industrial transformation and accelerate the implementation of the 2030 Agenda for Sustainable Development. As we all know, science, technology, and innovation are the core engines driving sustainable development. In the digital age, data and artificial intelligence are increasingly becoming key forces in driving economic growth, improving social well-being, and addressing global challenges. From May 1st and 2nd, the inaugural meeting of the UNCSTD Multi-Stakeholder Working Group on Data Governance was successfully held at the Palais des Nations in Geneva. At the chair of the meeting, I witnessed 165 representatives from the 54 member units and over 30 observers organizations to embark on this significant process. This meeting positively responds to the United Nations General Assembly Resolution 79/1, the Global Digital Compact, and naturally the Pact for the Future. And the working group will engage in a comprehensive dialogue on building a fair and interoperable data governance system. It will submit recommendation report to the 81st session of the UN General Assembly in 2026. As a global promoter of digital technology innovation, The WDTA has always believed that technological development must serve human well-being. Today's meeting is an important platform for us to put this concept into practice. Here, experts from academia, industry, government, and international organizations will jointly explore three key issues: how to unleash the value of data-driven by AI, how to advance AI empowered by data, and how to build a collaborative governance system that supports sustainable development. At the same time, WDTA is also highly concerned about the key issues of ethics, governance, and security that may arise in the widespread application of data and artificial intelligence, such as our AI STI, Safety, Trust, Responsibility Program. Through this side event, we hope to promote related discussions, further build broader consensus, and contribute our collective wisdom to building a safer, more trustworthy, and more responsible data and AI ecosystem. Dear colleagues, the realization of sustainable development goals requires global collaboration. Let us take this meeting as an opportunity to turn consensus into action and apply innovation to practice. Finally, I wish the Data+AI side event for the 10th STI Forum a complete success. Thank you for.
Thank you, Professor Major, for grounding our session with such a clear and compelling vision of global collaboration and responsible digital governance. With that foundation set by Professor Major, we now move into our keynote segment, featuring global experts who will share how AI and data are driving sustainable transformation across industries. Is Professor Ka here? Not yet. Okay, please join me in welcoming Professor Lee, who is a leader who brings deep insights for both academia and digital transformation. Professor Yale Lee is also the executive chairman of WDTA. Professor Lee, please go ahead.
Thank you, Norma. I have a slide to share. So Norma, can you see my slide?
Yes, very clear.
Good morning, New York. Good afternoon, Europe. Good evening, Asia. Thank you for joining this topic on data plus AI, opportunities and the challenges of a sustainable industry growth. As we stand at the crossroads of technological transformation, data and AI are not just tools. They are the engines driving industries toward a sustainable future. Today, I will explore how these technologies are reshaping education, healthcare, retail, and the data ecosystems, while addressing the challenges we must navigate to ensure inclusive and ethical growth. Let's begin with the numbers. According to UNCTAD Technology and Innovation Report 25, just released last month, the global AI market is projected to soar from $189 billion in 2023 to an estimated $4.8 trillion by 2023. Similarly, market research indicates the big data market will grow from $306 billion in 2023 to $743 billion by 2030, then reaching $962 billion by 2023. These figures underscore the rapid expansion of frontier technologies, evolving from generative AI to agentic agents, and eventually artificial general intelligence, or AGI. Data too is transforming from big data to a critical data factor in global economies. Agentic AI, which autonomously performs tasks and makes decisions, is revolutionizing key sectors. Let's explore its impact. Everyone has heard about AI agent and agentic AI after generative AI, such as a large language model. This table illustrates the difference between AI agent and the generative AI, and the agentic AI. In my view, AI agent can help individuals in specific tasks, but agentic AI can do a better job for entire workflow of an enterprise or even the industry. In this sense, I would say AI agent may benefit more for 2C scenarios, and agentic AI may benefit more for 2B scenarios.
Excuse
Generative
my interruption. Sorry, Liel, your slide isn't moving. Do you want to?
Can you see it?
I can see the whole thing, but we can't see the slide you were on.
Okay, maybe I will just.
Yeah, there we go.
Okay.
Looks good.
So did you see this slide? This is my second slide about untitled
Yeah, we
report.
didn't see that. We didn't see
Oh,
that.
you didn't see. Oh, okay. So I just maybe give you a few
A
seconds.
few seconds. Yes.
Yeah,
Thank you.
yes, scan through some numbers. Yeah, to 2023. So data and AI both will grow really, really big. Yeah, that's the message. Yeah, then this is the comparison table between AI agent and agentic AI. Okay. So yeah, so as I mentioned, agentic AI probably will change, entire workflow of enterprise. Yeah, maybe it will benefit more in some 2B scenarios. So I will give you some examples next. The first one is that, in education, agentic AI offers transformative opportunities. For example, personalized learning, tailoring curricula to individual student needs, automated grading and feedback, saving teachers time while providing instant insights, 24/7 tutoring support, ensuring students have access to help anytime, administrative efficiency, streamlining operations like scheduling and resource allocation, data-driven insights, helping educators identify trends and improve outcomes. Yet challenges remain. Ethical concerns, ensuring AI respects student privacy and avoids bias, implementation costs, high upfront investment can strain budgets, teacher resistance, educators may fear job displacement. Equity in access. Not all schools can afford cutting-edge tools. Over-reliance risk. Students and teachers must maintain critical thinking skills. The future of education lies in balancing AI's potential with human oversight to create inclusive, equitable learning environments. Next example is in healthcare. Agentic AI is equally promising enhanced diagnosis. AI can detect diseases earlier and more accurately. Research acceleration, speeding up drug discovery and clinical trials. Personalized treatment plans, customizing care for
Yes,
individuals.
yes, I can see it.
Okay.
Operational efficiency. optimizing hospital workflows and resource use, telemedicine support, expanding access to care in remote area. However, challenges include data privacy and security, protecting sensitive patient information, integration with legacy systems. Older infrastructure can hinder adoption. Ethical concerns, ensuring AI decisions align with medical ethics. Regulatory hurdles, navigating complex compliance frameworks. Trust and adoption, building confidence among patients and the providers. The future of healthcare hinges on secure, ethical AI systems that enhance rather than replace human experience. In retail, agentic AI is reshaping the customer experience, personalized customer experience, recommending products based on preferences, inventory optimization, predicting demand to reduce waste, operational efficiency, automating supply chain and logistics, fraud detection, identifying suspicious transactions in real time, customer support automation, chatbots that resolve issues 27 by 24/7. Challenges include data privacy and security, safeguarding customer data, integration complexity, merging AI with existing systems, ethical concerns, avoiding manipulative marketing practices, high implementation costs. Small retailers may struggle to adopt. Workforce adoption. Employees need retraining to work alongside AI. Retail's future depends on using AI to enhance customer trust while maintaining ethical standards. Beyond individual sectors, data itself is becoming a cornerstone of economic growth. In post-big data big data phases, two data frameworks highlight this shift. The first one is a data space. I'm sure Lars from IDSA will give us a comprehensive introduction to data space in his talk later. As data space related to industry growth, we have seen best practices from Europe and China. So the first one is the European industrial data space, originating from Europe. The EIDS promotes secure interoperable data sharing across industries. Its opportunities include economic growth, unlocking data-driven innovation, collaboration, enable cross-sector partnerships, standardization, creating framework from trust and efficiency. In China, the government has planned for over 100 trusted data space projects among 5 categories: trusted enterprise data space, trusted industry data space, trusted city data space, trusted person data space, and trusted cross-border data space. However, challenges like data governance, interoperability, and trust must be addressed to realize its potential. In China, the concept of data factor, this is a core data, it's a core economic access, or new oil of digital age. In China, data factors are, really, really popular, but I'm sure in countries outside, this, terminology may spread in the future. So this diagram is a government framework from China Data Administration. Opportunities include national governance, streamlining public services through data, marketplace development, creating platforms for data trading, innovation, fueling AI-driven solutions across industries. Challenges include data quality assurance, ensuring accuracy and reliability, trust and transparency, building confidence in data markets, data privacy and security, protecting user rights is very important. Interoperability, standardizing data across platforms. Pricing models, valuing data fairly. Data ownership, clarifying rights and responsibilities. Agentic AI may also play a pivotal role in unlocking the potential of these data ecosystems, but only if we address these challenges head-on. As we harness data and AI for sustainable industry growth, WDTA calls everyone to prioritize three things: ethics and inclusion, developing digital technology, including data and AI, that is fair, transparent, and accessible to all small businesses, developing nations, and underserved communities. Number two, regulation and trust, creating frameworks and standards that protect privacy and build public confidence. Third, collaboration and education, partnering across borders, as amplified by World Digital Technology Academy's DigiBridge program, which unites Nobel Prize winners, Turing Award recipients, academics, and professionals to drive innovation. In conclusion, data and AI are not just reshaping industries, they are redefining our future. Jensen Huang recently said, the winners of the last industrial revolution wasn't the country that invented it. It was the country that applied it. We would agree with him. It's a very clear AI plus data is a transformative and impactful as electricity and oil was before. And it's going to revolutionize every industry. So it's an industrial revolution. Thank you.
Thank you, Professor Lee. Data and AI fuel sustainable growth by enabling personalized services and operational efficiency in education, healthcare, and retail, as Professor Lee said. Yet they demand parallel focus on security, ethics, and cross-sector collaboration to fully realize their potential. Next, please join me in welcoming Professor Muhammadul M.O. Kha, Chairman of the UNCSTD and Vice Chairman of the WDTA, Vice Chairman of the UNCSTD and Chairman of the WDTA Education Council. Professor Kha, over to you.
Thank you. Thank you so much. And a very good morning to all of the participants and panelists. Can you hear me clearly?
Yes, we can.
Yes, it is indeed an honor to address this very important side event at the sidelines of the 2025 STI Forum under the timely theme, Data and Artificial Intelligence for Sustainable Industrial Growth. This is very timely. As Professor Lee shared with us, we stand at an unprecedented transformative moment in history where data and AI are not only redefining the contours of industrial growth, but also unlocking new frontiers of sustainable development. I must say, these must be guided by an efficient, effective, and adaptive governance mechanisms. We need urgently data governance and AI governance to help us to be able to unlock fully and meaningfully these new frontiers to ensure sustainable development, growth, and prosperity driven by smart industries. These technologies undoubtedly will reshape global value chains and make them more agile, smarter, and more adaptive, and more resilient and responsive. The pivotal moments we find ourselves today, where the advancements of technologies such as artificial intelligence, data analytics, and digital ecosystems, these are reshaping global, regional value chains, as well as national value chains, which will drive unprecedented productive capacities. It will also enable us to foster meaningful cooperation towards achieving the Sustainable Development Goals. How are these things reshaping our value chains? As Professor Yali shared with us, AI and data technologies are undoubtedly revolutionizing industries by optimizing supply chains. They're helping us to reduce waste, and in that process enable us to enable an efficient circular economy and yield the benefits of it. From precision agriculture to smarter logistics to predictive maintenance in manufacturing and to real-time energy optimization, AI-driven tools are enhancing productivity, as I mentioned earlier, and reducing waste and accelerate our path towards achieving the SDGs. AI-driven logistics platforms can help us solve some of the big challenges of climate, such as cutting carbon emissions by optimizing delivery routes, which will help us to further achieve the climate action on SDG 13. Furthermore, it will also help us to drive productivity by automating routine tasks and augmenting the capabilities and ingenuity of humanity. AI will boost industrial output maximally and will create opportunities for upskilling and for employment, contrary to the belief that it will take away employment. From those of us in the global South, particularly in Africa, these advancements holds profound relevance. Data and AI analytics will help us to leapfrog some of the traditional development barriers that are known. Mobile-based AI solutions we have seen across our continent increasingly empowering our smallholder farmers, facilitating for them and equipping them with real-time market data and climate intelligence to help to have resilient intelligence on crops. We have also seen these AI-powered platforms helping these smallholder farmers not only to have resilient crops, but also to optimize their yields. An example is in Kenya, AI-powered agriculture platforms increase yields in some reports of over 500,000 farmers by 20%. this is quite impactful in a scale. And if this is scaled up to many countries in Africa, it will certainly help us address or accelerate the SDG 2 on zero hunger. In health, we've also seen, as was shared with us by Professor Yali, that data-driven diagnostics are expanding access to services in underserved communities and increasingly used in the healthcare ecosystem. In trade and logistics, we've seen increasingly the digital tools are helping our SMEs and MSMEs to integrate into regional and global value chains with unprecedented agility and value creation. Second point is the importance of enhancing global cooperation. Data and AI will undoubtedly foster cross-border collaboration by enabling us to share platforms for innovation. We've seen open source AI models and data sharing frameworks that is helping many countries to co-create and co-develop solutions that are adaptive and contextual and tailored to their respective local needs. This requires our collective efforts and commitments to foster meaningful dialogue, such as what we are having now, hosted by WDTA, and cooperation across governments, private sector, academia, and civil society, as well increasingly the youth creators in the emergence of the ecosystem, digital ecosystems driven by data and AI, where our youth are at the center and at the front of it. So these global collaborations become hugely important and essential as we navigate through data and AI in its relevant to industries. However, to harness these technologies fully, we must ensure equitable access. But we have to go beyond just facilitating or ensuring equitable access. We have to usher in meaningful investments and collaborations to facilitate ownership. So access alone is not enough. Ownership of digital assets that are sustainable, safe, and affordable, to have that, to ensure that data and digital infrastructure are owned and not just provided access to. I think that's a very important point. We tend to focus mostly on access, which is very important. I don't want to minimize the centrality of access, but access in itself is not enough, particularly for those of us in the global South. Ownership, and there are different configurations of how ownership can occur, but it is important that the data and digital infrastructure are owned. Very essential point. We also have to foster digital literacy and also address the ethical, governance, and capacity gaps that continue to persist. We're looking forward to the mandated Secretary General's report on capacity building on AI, and we are also encouraged by the WDTA work on the education segment to build capacity and training facility and arrangements around building capacity on AI. We must address the challenges or the continuing challenges of digital divides, data and AI governance. And I take this at this juncture to urge participants and colleagues to add their voice on the efforts of the CSTD's working group on data governance that is chaired by Peter Major. A very important platform and an opportunity to address some of these challenges and issues. So all your diverse voices and inputs are important to ensure we have a coherent and impactful and value data governance that could propel and help industries in this space. It is also important for us to collectively address the challenges or the continuing challenges on data sovereignty and self-determination. These are very important issues for the Global South. Data sovereignty, data self-determination, data flows, cross-border data, data commons, data stewardships, interoperability, human-centered and human rights approaches, adaptability, accountability, privacy, security, safety. These things must be addressed as we move and ensure that our manufacturing and industries are enabled by data and AI. This will call, as I mentioned earlier, for meaningful collaboration, but more strategic and impactful innovative investments. We must invest in our local AI talent. We must invest thought leadership on ethical frameworks. We have seen, for example, in Africa, in Nigeria in particular, an AI policy roadmap. And most countries are embarking on an AI policy roadmap that covers data and AI-enabled industrial growth. These are critical. It is also important to also include inclusive growth when we are looking at these policies. It calls for inclusive policy frameworks and, again, cooperation, North-South cooperation and South-South cooperation that prioritize the unique and diverse needs of the different membership that from the developing world, whether they are small island states or landlocked countries or countries that do not have or have limited capacities. We just cannot move forward as passive recipients, but to be co-creators of solutions. I will conclude by saying that data and AI are not just tools. They are catalysts for equitable, sustainable industrial growth. And for us to fully harness their potential, we must prioritize smart, inclusive policies, corporations, capacity building in the Global South, and bold investments, especially in the Global South. Together, I have no doubt we can turn technological potentials into shared prosperity and a faster path towards accelerating the SDGs and make them more relevant. So let us commit, all of us today, to build a digital ecosystem that is inclusive, that is secure and sustainable, where data and AI serves humanity, industry, and the planet alike. The future is not only about innovation. It is also about innovation that uplifts, that empowers, and that unites, and that creates value and prosperity for all. And I thank you.
Thank you for that powerful speech, especially the example of how the mobile-based AI is already making a difference in helping farmers grow smarter and end hunger one yield at a time. And also thank you for highlighting digital inclusion isn't just about equitable access, but also about driving real ownership, be co-creators of solutions. Thank you very much. To continue this dialogue, I'm pleased to introduce you to our next keynote speaker, Mr. Lars Nagel, CEO of the International Data Space Association, whose work focuses on building trusted data ecosystems across international industries. Mr. Nagel, over to you.
Thank you very much for that great introduction, dear esteemed audience, dear friends from WDTA and from CSTD. It's a great honor to be here, and also for me and obligation to contribute to the important goals that Ambassador Carr and Peter Major have just mentioned. I would like to make you familiar with data spaces and why they are key to unlocking AI's potential and to really lever all the promises and needs that just have been mentioned. So let's start with what AIs need. So there's a big appetite of AI for data. And here I would like to really underpin that currently we are in a situation, and we see that coming, that not enough data is available. So there's a need for more data, much more data. Most of the data is not shared. Different studies, so something between 80 and 98% of the data is not shared. So that is actually, well, most of the data. And we see here the recent study from the MIT that soon, somewhere in 27, the AI training will no longer find enough data to really satisfy the appetite. So we need to open new data sources, and therefore we need new mechanisms. Then the other view graph that you can see here is from the Open Data Institute. When we talk about data and, well, what data to be used for AI and for training and the large language models, then we really need to see that there's a really different kinds of data. We see that spectrum. So it's from open data via shared data to closed data, and where I would like to focus is on the closed data. So there are a lot of reasons why organizations do not share data. And we also need to respect that the data comes in different formats, in different sizes. So therefore, it's also from that end a big challenge to get all the data together. Data spaces enable the aggregation and sharing of vast amounts of data from various sources, and I will share with you how that could work and what will be done there. I would like to start or to add that aspect here. When we talk about data and AI, data governance is the important thing to really come up with what we call trustful AI. So in the very sense that Ambassador Carr has just mentioned. So we want AI to do good, to follow the Sustainable Development Goals. We want to have data sovereignty. So in the first, it's humans that take decisions what happens with data, and therefore it is so important to have the new working group on data governance at the CSTD to come up with a global framework. So because that is what we cannot leave to machines. And that is so important for AI. We need the trust, because with that, we can decide if this data source will be really opened or better not. And then we move on. And here is where the machines come into play. And what I want to stress here is when we talk about, well, AI, data sharing, value creating based on data, we also need to talk about machine readable data and data usage policies. Because what we need, what AI calls for, is not only a vast amount of data, but also processing that vast amount of data. So things need to happen like in light speed and machine readable. So therefore, what we can come up with in the context of data spaces is that we interpret the policies that are made by human and then express them machine readably in policies, and then match them with claims that someone has, and therefore you can negotiate, like, is that organization, that person, that agent allowed to use my data or not, and under which circumstances or conditions. That is what data sharing is about, what we need for AI, and currently this is not easy. That is not able to be done in a machine readable manner. So here's where data spaces come into the play. and why this is a perfect fit. So we need many data sources, so we need to talk about collaboration and data sharing. So what you can read here is, well, a lot of data is not shared because organizations are not sure what happens with the data. They don't want that someone else benefits from their data and someone is left alone. Also following what my previous speakers have said. And even like more and more open data spaces are for very good reasons being restricted. So we need to overcome that so that organizations may be willing to share data, but only under certain specific conditions. And here we need to bring in the context or concept of data sovereignty. So having control over data, the rights and the usage policies attached to it. We need to add trust into that process. So how to, well, get data and make them useful and used for AI and whatever. And therefore, we need to come up with a fair value exchange. That is exactly what data spaces can enable. And if we want to depict that, we have here this view graph where the main principles that we need for AI, data governance, data management, and data quality are embraced by, well, the true leading principles. So the trustful artificial intelligence and the sovereign data sharing. And, well, in data spaces and with the concept and the governance framework of data spaces, we come up with terms like the data space authority, software components. With that, you can control what happens with your data, processes, and also the semantics of data, how to understand it, and, well, how to add vocabularies so that really cross-domain data sharing is or may happen. Well, short introduction what data spaces are. So data spaces are like, you can compare it to the internet. So it's a sum of all endpoints that are able to share data with each other under certain conditions. So therefore, we are talking about a mostly decentralized or federated data architecture. So no physical data integration, no man in the middle, no platform. We leave the data where it is. We only talk about metadata and the usage policies. Data spaces enable interoperability between different organizations and software systems, no silos, no vendor dependency. Data spaces provide data sovereignty and traceability. That is what you need, for example, when we talk about IP rights for AI. And it ensures that we have trusted participants, but also trusted services and components via which the data travels while being processed. And here, so data spaces embrace all the values that we want to see for data sharing, so that it can be trustful, that it can be inclusive, and following all the values that we are sharing here in this context. So I don't want to read through these 10 fundamental principles, but that is what IDSA has been set up with all our members from all over the world. And you might see some buzzwords there that fit to what has been said before. So your data, your choice. We are not talking about a single platform that rules them all, and so on. So therefore, let's think about data spaces when we want to talk about the next era of AI. And what I just mentioned is a new capability that we need for data sharing. So the current internet and the internet protocols cannot really deal with usage policies attached to data sets. So we are in the internet talking about open data. And as I mentioned at the beginning, that is exactly the problem when we want to talk about data ownership, as it has been mentioned. So therefore, what is really important is like attached usage policies or a data contract to a data set, and then negotiate with two parties like, okay, can you use my data and for what purpose? And that is exactly what we want to do in order to respect individual rights or domain rights with one data set. And therefore, we've created the data space protocol, which will become an ISO standard by end of that year, to come up with very fundamental capabilities that we need to make happen what I just mentioned. And we also want to focus here on innovation and industry relevance. So you can see that we have worked with a lot of big and relevant players from the IT side, but also from users to define this protocol. And on the right-hand side, which is more important, you see that the data space protocol is already on a global path, so to say, being adopted in different economic areas. You see Europe, China, Japan, the US, other countries here represented, and this is a first step. And now we definitely need to bring it elsewhere. The global South is very important for us, and that is what we and why we are engaged here in that context. The promises are manifold. Most has been mentioned already by Professor Ye Li before. So I want to point you to what is at the bottom right part. So we have the data space radar, where we have listed more than 180 data space endeavors all over the world in all domains. You can please scan the QR code and have a look at it. And therefore, data spaces bring value to all domains and cross-domain. So the automotive sector with supply chains all over the world, improving agriculture and food production, enabling smart cities to flourish and serve citizens' needs. Then also, fighting fake news, for example, or digitalization of cultural heritage. This is all data space activities, and there are currently data space projects happening all over the world. We also have very clear use cases, for example, in the health, to really find new insights on genome data or on cancer imaging, and, well, endless more. Please have a look at that, get inspired, and let's discuss that in the course of the WDTA and elsewhere. I want to conclude my presentation with this slide here. For sure, data spaces are the next big concept of data management, to really add to the data economy what is missing, attaching usage policies to data sets, and coming up with soft infrastructure so that these usage policies can be respected and technically enforced, so that only that happens to your data what you want to happen. And this is a very powerful governance scheme to make data economy happen, but especially to make AI and to bring AI there where it wants to go, following the growing appetite of AI. But, well, for most, so data spaces are supporting sustainable development goals. I've mentioned some of the data space endeavors that are clearly related to some of these goals. So environmental sustainability or social equity. This is something that we can realize, and this is not like a promise, it's already a reality. And I'm looking forward to get in contact with all of you to see that we bring data spaces everywhere for cross-domain data sharing and, well, cross-country data sharing. Data spaces are an important thing. We all believe in data spaces as an enabler for our future wealth, and I'm looking forward to discuss all these aspects with you in this context, in other contexts. Get in touch with me, and looking forward to all other discussions. Thank you.
Thank you, Mr. Nigel. Thank you for showing us how we may have trustful data sharing. And building on that perspective, let's now hear from a leading voice in computer science and research innovation, Professor Jeanette Wing, Executive Vice President for Research and Professor of Computer Science at Columbia University. While Professor Wing cannot be with us in real time today, she has shared a recorded message that speaks to today's theme. Let's take a moment to hear from her. We'll play a video. Thank you.
Hello, I'm Jeanette Wing, the Executive Vice President for Research and Professor of Computer Science at Columbia University. And I'm going to talk to you about my new research agenda, what I call trustworthy AI. For certain tasks, AI systems have achieved good enough performance to be deployed in our streets and our homes. Object recognition helps modern cars see. Speech recognition helps personalized voice assistants converse. For other tasks, AI systems have even exceeded human performance. AlphaGo was the first computer program to beat the best Go player in the world. The promise of AI is huge. They will drive our cars. They will help doctors diagnose disease more accurately. They will help judges make more consistent court decisions. They will help employers hire more suitable job candidates. However, we know these AI systems can be brittle and unfair. Adding graffiti to a stop sign fools the classifier into saying it is not a stop sign. Adding noise to an image of a benign skin lesion fools the classifier into saying it is malignant. Risk assessment tools used in US courts have shown to be biased against Blacks. Corporate recruiting tools have been shown to be biased against women. How then can we deliver on the promise of the benefits of AI, but address these scenarios that have life-critical consequences for people and society? In short, how can we achieve trustworthy AI? I'd like to talk about trustworthy AI from trustworthy computing. For decades, the computer science community has made progress in the area of trustworthy computing, where trustworthiness has come to mean the properties such as reliability, does it do the right thing? Safety, does it do no harm? Security, how vulnerable is it to attack? Privacy, does it protect a person's identity and data? Availability, is the system up when I need to access it? And usability, can a human use it easily? And computing has come to mean the combination of hardware and software, but also people who use the system. From trustworthy computing to trustworthy AI, we're upping the ante. Not only do we mean the properties of trustworthiness from trustworthy computing, but we are now talking about new properties we expect of these computing systems: accuracy, robustness, fairness, accountability, transparency, interpretability, and even ethical issues of AI systems. So I mean by these new properties for trustworthy AI, all the properties of trustworthy computing plus accuracy, how well does the AI system do on new unseen data compared to data on which it was trained and tested? Robustness, how sensitive is the outcome to a change in the input? Fairness, are the outcomes unbiased? Accountability, who or what is responsible for the outcome? Transparency, is it clear to an external observer how the system's outcome was produced? Interpretability, can the system's outcome be justified with an explanation that a human can understand and or that is meaningful to the end user? And in terms of ethical issues, was the data collected in an ethical manner? Will the outcome be used in an ethical manner? So the question now is, how can we achieve trustworthy AI? And I just want to propose one approach of many approaches that are currently being pursued, like the usual approaches of validation and testing. The one approach I want to advocate is formal methods. And to be honest, the most important reason I want to set forth this new research agenda is to bring together three different communities: the formal methods community, the trustworthy computing community, and the AI community. So from traditional formal verification, we have the following formulation of what it means to prove a program is correct or to show that a system satisfies a particular property. And this formulation has three pieces. M stands for the program or the protocol, or it could be a mathematical model of a concurrent or distributed system. The double turnstile stands for the logic and or tools that embed that logic, such as model checkers, theorem provers, and SMT solvers that we can use to reason about the program. And P stands for the trustworthiness property we care about. In traditional formal verification, where we're trying to prove a property of a piece of code, we use Boolean logic, discrete logic. And we have made so much progress in this area that we have actually characterized these kinds of properties formally into safety properties and liveness properties. And we usually write these properties formally through some kind of temporal logic. From traditional formal verification, we also sometimes explicitly model the environment of the system in which the program operates. For instance, E could be the operating system, or E could be the physical environment of a particular cyber-physical system. Now, if we want to verify AI systems, we're also upping the ante. Let's reinterpret what M satisfies P means. M here could be a model that we learn through machine learning. But in the end, as we know, M is also just a piece of code. And this gives me hope that we can apply some of the techniques that we've learned over the decades in formal methods to machine learning models. Here, the logic is very likely going to be probabilistic in nature because of the probabilistic nature of M and because of the probabilistic nature of the trustworthiness properties like robustness and fairness and so on. So P here on the right stands for a trustworthiness property relevant to an AI system. And as I'm suggesting, it could very well have to be written in some kind of probabilistic logic. What's most interesting and most important in thinking about how to verify an AI system using formal logics is the explicit characterization of data used to train the machine learning model, data used to test the machine learning model, and of course, the data that we haven't even seen yet, where the machine learning model is meant to be used in terms of real deployment. So one can think of a model of data being something like a stochastic process or a data distribution, for instance, that generates the data inputs on which M's outputs need to be verified. So this is my formulation of what it means to verify an AI system with respect to a trustworthiness property. D, M satisfies P. And what I want to do very quickly in my remaining time is just to walk through some of these elements in more detail. Remember, the two main differences between traditional formal methods in verifying computing systems with respect to traditional trustworthiness properties are the need for probabilistic reasoning and the role of data. In terms of the role of data for this talk, I'm only going to talk about two questions: specifying unseen data and what do we quantify over, because those are new questions that the formal methods community hasn't had to address before. So why is there a need for probabilistic reasoning? Well, first, the machine learned model, M, is semantically and structurally different from a typical computer program. It's inherently probabilistic. Internally, the model itself operates over probabilities and outputs results with assigned probabilities. And structurally, M is machine generated and unlikely to be human readable, which can be viewed as another kind of intermediate code, which again gives me hope that some of the techniques from programming languages and formal methods might be germane to verifying AI systems. P may be formulated over continuous, not just discrete domains, and are using expressions from probability and statistics. Robustness properties for deep neural networks are characterized as predicates over continuous variables. Fairness properties are characterized in terms of expectations with respect to a loss function over reals. Differential privacy is defined in terms of a difference in probabilities with respect to a small real value. So the properties P that we care about for trustworthy AI and themselves may best be formulated over these continuous domains. And finally, the logics in which we use to verify that M satisfies P are likely to be probabilistic or hybrid. So we need scalable and or new verification techniques that work over reals, nonlinear functions, probability distributions, stochastic processes, and so on. Now, what about the role of data, D? I like to distinguish between available data, the data at hand, which is used for training and testing, and unseen data, data over which M needs or is expected to operate without having seen it before. So first, we have to ask questions about the data collecting and partitioning. How can we partition an available given data set into a training set and a test set? What guarantees can we make of this partition with respect to a desired property P in building a model M? How much data suffices to build a model M for a given property P? Does adding more data to train or test M make it more robust, fairer, or does it not have an effect with respect to the property at all? What new kind of data needs to be collected if a desired property does not hold? Now, here's a very hard problem. Specifying unseen data. How do we specify the data and or characterize properties of the data? By definition, it's unseen. So how are we supposed to know what we haven't seen yet? We could, as I mentioned earlier, specify D as a stochastic process or data distribution via its parameters. We could use a probabilistic programming language, for example, STAN, which is used to specify statistical models. But what if large real-world data sets that do not fit common statistical models, like normal distributions or Gaussian distributions, or which have thousands of parameters, which is more like what we are seeing today, where we collect tons and tons of data and use that data to build these modern machine learning models. And there is another issue with respect to specifying unseen data, and that is breaking the circular reasoning. To specify unseen data, we need to make certain assumptions about the unseen data. Would these assumptions not then be the same as those we would make to build the model M in the first place? That is, how can we trust the specification of D? So to break this circular reasoning, there are a couple of approaches we might pursue. One is a repertoire of statistical tools, which I'll get to in a later slide. Another is to start by an initial specification that is small or simple enough that can be checked, say, by manual inspection. And then we use this specification to bootstrap an iterative refinement process. And this process is very much like the counterexample guided abstraction and refinement method in formal methods. And then finally, how does the specification of unseen data relate to the specification of the data on which M was trained and tested? The second big new question for trying to verify trustworthy AI systems is, what do we quantify over? In traditional formal methods, we strive to prove that for all x, p of x, for instance, for all values of a particular variable, some property will hold. And if we can prove it for all values of a particular variable, then certainly for any variable which is actually used in practice, P will hold. But for AI systems, we do not expect M to work for all input data or for all data sets. So what can we quantify over? How can we specify the class of distributions over which P should hold for a given M? It might be property dependent. For robustness, in the adversarial machine learning system setting, we might want to show that M is robust to all norm-bounded perturbations D. More interestingly, we might want to show M is robust to all semantic or structural perturbations for the task at hand. For example, computer vision. Here, we know that adding a little noise to the picture of a panda might fool a classifier into thinking the panda is actually a gibbon. So this classifier is not robust to a particular perturbation. How about a different property, like fairness? For fairness, we might want to show the machine learning model is fair on a given data set and all unseen data sets that are similar for some notion of similar. For example, the famous COMPASS data set showed that for recidivism risk, the model is potentially biased against Blacks. So in some work that I did with my colleagues that was published in NeurIPS last year, we showed how easy it is to take a model that has been deemed fair on a given data distribution and very slightly reweight the data distribution to make the classifier unfair. So in this case, this fair model is not very robust. And in the NeurIPS paper that we published, we showed how to build a robust fair model. And then let's now turn to the verification task. There are many questions once we can characterize M and P to determine how can we actually do the verification in an automated way or semi-automated way. I'm not going to read these questions for the sake of time, but you'll find them in the CACM article I published in October of this year. So let me now say that there are many opportunities for formal methods, not just the ones I mentioned. We could look at the task and try to use the task to help narrow the search space. We could take a completely different approach. Instead of trying to verify after the fact, we can construct the model to have the trustworthy property from the beginning. That's the correct by construction approach. We also want compositionality so that if you prove one part of a system is trustworthy in some way, and another part similarly, you want the composition of the two parts to also be trustworthy with respect to a particular trustworthiness property. That's a very big challenge, even for traditional computing systems and for many traditional trustworthy properties. And then, harking back to my previous remark about statistical methods for model evaluation and model checking, we can borrow from techniques in statistics that help us perhaps show that the initial model is something we can trust, using sensitivity analysis, prediction scoring, predictive checking, residual analysis, and model criticism. So I will close here with just a reminder of how I characterize how trustworthy AI meets formal methods in this four-part formulation. Thank you very much.
Thank you very much. Well, for the time's sake, let's just go ahead and jump into our next critical theme. Please welcome our two distinguished speakers who will bring a fireside chat. Mr. Ken Huang, Vice President of Research, CSA GCR, and Mr. Chris Hughes, CEO of Acquia, 20 years of cybersecurity leadership. Floor is yours, gentlemen.
Excellent. Thank you for the introduction. I know we're we're tight on time, so I'll dive into things on our end. We're going to focus on the intersection of agentic AI and data security, as well as some related topics around threat modeling and zero trust and things of that nature. But just for a quick kind of refresher or level set, can you kind of help us understand what is agentic AI? How is it different than traditional AI or LLMs, for example, before we dive in a bit?
Sure, yeah. Thank you, Chris. So agentic AI, basically, it has a level of autonomy that the general, like a generative AI application does not have. It has intelligence, it using the memory, and it also have tool use. Yeah, so that's can have the difference.
Yeah. Yeah, the way I've heard it, kind of easily explained is like, the LLM, think of the LLM as the brain, and agentic AI is now giving that brain arms and legs. Like it can go do things,
Correct.
interact with third-party services, tools, environments, can actually take autonomous actions, right, to some extent, whether fully autonomous, semi-autonomously, things of that nature. So as we look at agentic AI, how do you see that intersecting with, kind of the concept of data security?
Yeah, so agentic AI, I think we are in the area of agentic AI transformation from the traditional digital transformation. If you look at the digital transformation, it's really digitalize the workflow, but the workflow itself has to be programmed in the program logic kind of. With agentic AI, the idea is really it's a data-driven insight and a data-driven action, and you have a dynamic workflow which will be generated on the fly. If you look at the traditional like ERP or CIM application, it's more like you have a complex workflow logic in program logic, but eventually it will be a CRUD operation or CRUD operation on the database. Now with agentic AI, the data will driven your workflow. So you have a more dynamic workflow. You can code generate it. There's this implication of the security. So the data itself, who has access to it, and what kind of identity will have access it for how long, and those has an implication to the security.
Yeah, I agree. And, there's also been another trend underway for the last several years, which, is kind of taking the phrase of zero trust, which means, no implicit trust, trust but verify, those kind of catchphrases we hear. And it includes concepts like least permissive access control, microsegmentation, limiting the blast radius, for example, of incidents and breaches. How do you see that playing into agentic AI now that we have potentially these agents within the architectures that are able to go out and interact with third-party services, tools, take actions on their own. And you talked about the identity piece, for example. How do you see, agentic AI kind of coming into the fold when it comes to zero trust?
Yeah, so I had a keynote panel at just the ISA conference about this topic. So that's certainly is dear in my heart in terms of talking about that. Uh, in terms of zero trust, I think you hit the major point. They are very important. The traditional, or when you're talking about zero trust, it's really hard to implement. And some enterprise, if they have money, they implement it, but it's an ongoing process. With the agent, it's what my point is imperative. It's a prerequisite of the agentic AI deployment. Without zero trust continuously deployed, agentic AI will have the security issues. Things you're talking about in terms of trust model, you cannot trust the model. You have to validate every input to the model and every output from the model. And if you're using a RAG pattern for the agentic RAG, you have to validate the RAG vector database avoid the data poisoning on the memory, on the context, on the vector database, right? And also if you're using the agentic framework such as Clue AI, AutoGen, LangGraph, those framework are orchestration framework. They are not security framework. So you need to build your own security framework around it. I have open source the zero trust framework, which has adapted to Clue AI and AutoGen, so people can use it for authentication access control, especially the dynamic access control. The idea is you cannot have the agent to assume the human identity, have the human identity all the time. Example, like if you have a HR resource person, she has identity, and for one task, she may be able to put the advertisement for a job post, right? But she may not, for that agent, she should not have access to the salary data of the employee. So it should be really task-based. So the policy engine really should say what kind of task you are in and what identity you have, then assume the subset of a human identity. Uh, right? Then you can execute to give. So if you are job posting as a task, you should not really post the salary data. So that is a dynamic context and task specific. People thinking, some people have the misconception that if I just have this identity or agent identity, assume the person's identity, that should be good enough. That's not.
Yeah, I like where you're headed with that. A lot of those concepts, while agentic AI may be new, right? The concepts that you're talking about in terms of right sizing permissions, scoping, the tasks that can be carried out appropriately, maybe having a subset of access control, kind of attributed to the agent to take action. These are fundamental security concepts just needing to be applied right in a new context of agentic environments and architectures. And speaking of, this need for validation, right? You talked about the need to validate the inputs, the outputs, things like that. There is another age-old, kind of security practice, which is called threat modeling, that we look at systems. We think about, the kind of 4 questions. I'm not going to rehash all of them, but what are we working on? What can go wrong? Those kind of things. And there's various threat modeling frameworks out there, Stride, Pasta, Lindun, and others, that are popular. But you came up with another one. Talk to us about first, why threat modeling is an important piece of agentic AI architectures and security, and then also what is this Maestro framework that you came up with? How does this different, and why do we need it?
Sure. Yeah. Thank you, Chris. Yes, the Maestro framework published by CSA Cloud Security Alliance, and since they are used by many research papers, and some company also use it for their work. So the key idea is you mentioned Pasta or Strida, they are really good. They can still be used. We're not really exclude this, right? But they are not sufficient, especially in terms of what I call the dynamic identity, which we just discussed, and also the autonomy of the agent and a non-trust boundary, because in the traditional threat modeling framework, you assume there is trust boundary. Everything inside the trust boundary, you can threat modeling it. Outside, you don't care because that's other people's. You just need the data flow within it and maybe outside, but just outside. But what outside of this trust boundary, that's another threat modeling other people has to do. That's not the case with the agentic AI, especially the majority of traffic in the future will be the agent-to-agent traffic. And Google just recently published the A2A. The idea of the agent-to-agent protocol is really for the agent in GCP to talk with agent in Azure or AWS, and it's for business to business applications. So non-trust boundary, it's certainly it's not in the traditional framework. And then there's a complexity in agent-to-agent communication and orchestration that will be really hard for traditional framework, Strata or Pasta to deal with it. So we have like 7-layer architecture and also cross-layer. You can deal with it. And then you have the non-determinism, right? Because the model itself is non-deterministic. It has erratic behavior. So all this is need a new framework. So this new framework is 7 layers. The model is the first layer. Very quickly go through it. Data is the second layer, especially the data like in the vector database or in the SQL database. And then you have the agentic framework. After that, you have a deployment environment. If the idea is if you can deploy the agent in a container or in a Kubernetes pod, it's a little bit more secure than you just directly deploy on the server, each EC2 server or whatever server it is, right? And also make sure the configuration is secure enough. And then you have the evaluation and benchmark or logging observability layer, which need to be secured. And then you have the security layer. Eventually, you use the final layer is the agentic ecosystem, which is enabled by A2A. And then the cross layer, like there's certain threat could be in cross layer. And we actually use that to model the MCP and A2A protocol and find some of interesting threat. We publish it in the archive paper.
Yeah, I definitely recommend people check out the paper. I read it last week on a trip to RSA myself, and it was cool to, one, get familiar with the Maestro framework, and two, see it applied in a real practical context, to MCP and A2A in terms of, these protocols that are emerging and how we can use a more aligned threat modeling framework that's aligned with agentic AI. Last question. I know we're tight on time here. There's the rise of quote unquote vibe coding. Kind of developers leaning into these LLM coding assistants and just going with the flow, right? Whatever it produces, we use it. We don't necessarily validate or verify, that it's necessarily secure. What are your thoughts on the rise of vibe coding and, kind of how that intersects with AppSec and security more broadly?
Yeah, so vibe coding is here. It will stay here because of productivity gain. I use vibe coding myself using Windsurf. I think it's a really good tool. There's also a lot of other tools coming, like a Charter LLM. I tested. But anyway, Microsoft said they have 30% of people using coded AI code to generate their code. Google, 25%. But people also did the research from Zurich. They find like even the best model, the Sonnet 3.7, have like 30% insecure code will be generated. So you cannot really trust the code generated by vibe coding. And some people actually deploy the code and by vibe coding, tested it successful and deployed in Verso with V0, right? Verso the internet, and people, and he has a secret key in the code. So people use this secret key and use all his credit. So this happens. So yeah, for that, actually, we publish papers at the Cloud Security Alliance, ask what is needed, especially tie it with OWASP, like LLM top 10, and some of the rules that cursor rules that you can apply when you generate code. Hopefully, it can. I think it can make it secure. This is the key idea is web coding will be always exist. It's always here. How we secure it, there's a different way. The initial way is really to define the rules because cursor, Windsurf, you can always define rule and it will, in most cases, it will obey it, right? Sometimes it hallucinate. If you ask it, you always have to generate authentication, authorization code. You always should not generate like store or deploy the .env file to the GitHub. It will do this for you. Yes.
Yeah, I agree with you. I think the vibe coding is going to be here to stay due to the boost of productivity, and it's going to be up to us to kind of implement, secure prompting and roles configurations, settings, et cetera, to kind of facilitate secure vibe coding, if we want to call that a thing. But nonetheless, a lot more we can talk about here. Again, Ken dropped a lot of references to some great publications he's made with Cloud Security Alliance on threat modeling with the Maestro framework, MCP and A2A, secure vibe coding, and more. So be sure to check those out. And I'll pass it back to the team here.
Thank you, Chris.
Thank you, Chris. Thank you, Ken. Thank you both for your thought leadership and real world experience on responsible and ethical agentic AI deployment. Thank you very much. To conclude our session, I'd like to invite Ms. Melon Xu, Executive Director and Assistant to Chairman of WDTA, to offer closing remark. Ms. Xu.
Thank you, Norma. Yes, speakers and my guests, I'm Melon Xu from WTTA. First of all, I'm truly grateful to our speakers and everyone online for your precious time and valuable insights. In this 1.5 hour Data and AI side event, Professor Peter and Professor Carr provide valuable insights into data and AI governance, highlighting the key practice and frameworks from the United Nations and international communities. Professor Lee explored the opportunities and challenges of data and AI with a particular emphasis on security consideration. Mr. Lash shared the IDSA's advanced experience in data space to promote AI development, and Professor Win shared the research on the Trust AI focus on the scientific advancement, while Ken and Chris provide a good discussion on the innovation AI application and the AI agents. Wow, really a short time, but rich insights. Thank you again to my esteemed speakers. Last year, at the Summit of the Future, UN Secretary General Mr. Antonio Guterres said, "The future of digital technology belongs to the youth." While WTD believes in that and we take action. Today, I'm glad to tell you about an exciting event. Why CAIO Youth Digital Leader Forum is coming up. The UNISD and the WTD will host it together on July 7, 2025 at the Paris Nations in Geneva, a place with a long history. The YCIO Forum aims to help young people develop responsible leadership in the digital era. At the forum, WTTA will update and issue a new AI competency framework and start new projects, such as creating a fund to help young people start and grow their research and business. And we will present the Youth Digital Leaders Award, recognizing transformative innovations and impactful contribution for young leaders. Young people are not just the user of the technology. We are making it, change how it works, and keep it for good. I invite you all to attend these important events, share your thoughts and collaboration with people from different business, science, and countries. Finally, thank you for coming and working with us. Let's use AI and data help people and create happy lives. Thank you.
Thank you, Ms. Xu, and to all our participants. And again, we warmly invite you to join us on July 7th in Geneva at the United Nations European headquarters for the Youth Digital Leaders Forum. And thank you once again to all of our distinguished speakers, guests, and participants from all around the world. As part of the 10th Multi-Stakeholder Forum on Science, Technology, and Innovation for the Sustainable Development Goals, this side event has reaffirmed the power of collaboration, ethics, and AI technologies to shape a better, more inclusive future. This concludes our session on Data plus AI for sustainable industry growth. We wish you a meaningful continuation on your STI Forum 2025 journey. Thank you and goodbye.
And I think we can take a screenshot together. What do
Yes,
you
sounds
think?
good. Are we all
Yes,
here?
Professor
Okay.
Carr also online now.
Perfect. Professor Ka, could you please have your
Let's take
video
a
open?
screenshot, open your video, and say hi and goodbye.
Thank you, everyone, again.
Bye-bye.
Thank you. I think Professor Carr is coming. Yes.
I saw him. Yes, he's here. There we go. Did we get the screenshot?
Yes.
Yay, good job.